How are you? In the previous class, we were discussing about the oxidation and reduction. In that class, we discussed about the four bases of oxidation and reduction. That was on the basis of oxygen, on the basis of hydrogen, on the basis of electronegative element, on the basis of electropositive element. Let me remind that. Okay. First, on the basis of oxygen, according to which the addition of oxygen is known as oxidation, while the removal of oxygen is known as reduction. Our second base was hydrogen, according to which the addition of hydrogen is known as reduction, while the removal of hydrogen is known as oxidation. The third base of our definition was electronegative element, according to which the addition of electronegative element is known as oxidation, and the removal of electronegative element is known as reduction. And fourth of our basis was electropositive element, according to which the removal of electropositive element is known as oxidation, and the addition of electropositive element is known as reduction. Okay, now let me discuss the fifth one, that is electronic concept, or we can say that on the basis of electron. According to this concept, removal of electron from a chemical species is known as oxidation, while addition of electron in a chemical species is called reduction. Removal of electron, oxidation; addition of electron, reduction. Okay, now let me discuss some examples and try to elaborate it some points. First one, that calcium remove two electron and make cation. Second one, Fe plus 2, when remove the electron it convert into Fe plus 3. Third, chloride ion Cl negative, remove the electron that it convert into neutral atom. So we can say that in oxidation, the neutral atom, if that is a neutral atom, then it convert into cation. If it is cation, then it's increase in positive charge, and if it is anion, then it's a decrease in negative charge. That means these three conditions are due to oxidation. If that is neutral atom, then it will convert into cation. If that is already cation, then it will increase in positive charge, and if it is anion, then there is decrease in negative charge. Like that, here that was negative, but here decrease. Okay, now similar case we can consider with the reduction. In the reduction, there is addition of electron. So if it is neutral atom, then there will be anion formation. If there is cation, then due to the addition of electron, its positive charge will decrease. And if it is anion, then addition of electron will increase its negative charge. So we can say that due to reduction, neutral atom, that is anion, neutral atom will convert into anion. If it is positive, that is cation, then there will be decrease in positive charge, and if it is anion, then increase in negative charge. Okay, so these are five concepts of oxidation and reduction. Now if we summarize all of these, then we can say that addition of oxygen is oxidation, removal of oxygen, reduction. The removal of hydrogen, oxidation; addition of hydrogen, reduction. Addition of electronegative species is oxidation, removal of electronegative species is reduction. Removal of electropositive species, that means which have positive charge, generally have positive charge or have tendency to accept positive charge, that means may make cation, that is electropositive species. If it is removing, that is oxidation. If it is adding, then it is reduction. And fifth one that we discussed now, removal of electron is oxidation and addition of electron is reduction. There was a sixth one which is generally used, that is oxidation number concept, but in our syllabus it is not, so I didn't discuss about it, but here we can discuss little bit about it. Firstly, on the basis of that, let me differentiate oxidation and reduction. According to this concept, increase in oxidation number is known as oxidation, while the decrease in oxidation number is known as reduction. Now the question comes in our mind that what is oxidation number? The charge present on an atom is known as its oxidation number. Clear? Increase in oxidation number, for example like this, Fe plus 2 converting into Fe plus 3, that is increase, that's come in the category of oxidation. As you know that from the plus 2 to plus 3 it have to remove one electron, and removal of electron is known as oxidation. Clear? Decreasing, if we oppositely take that, then we can say that Fe plus 2 plus 3 converting into Fe plus 2, and you know that for converting plus 3 to plus 2 it have to receive one electron, it has to receive one electron, that means addition of electron, and since addition of electron is known as reduction, so that is decrease in oxidation number, that comes in the category of reduction. Now our next topic is redox reaction. In nature, both oxidation and reduction takes place together. Both oxidation and reduction takes place together. That means they cannot found separately, because as we discussed in earlier class that if someone is donating electron or if someone is donating oxygen, then it must that some other one is receiving. Okay, means suppose one of the element donating oxygen, suppose these are two substances, and that is oxygen, I am saying that addition of oxygen is known as oxidation. If there is addition, then here is removal also. I am again doing that, oxygen was attached with that, now after that I attach with here, so it is oxidized but it is reduced. So that means in complete reaction both oxidation and reduction takes place together. That means in a complete reaction one substance is oxidized, then other one will reduce. Thus we can see that oxidation and reduction are half reaction if we consider them individually, and collect them, then the reaction formed is known as redox. Re stand for reduction, Red stand for reduction, Ox stand for oxidation. If we make a simple definition, then we can say that those reactions in which both oxidation and reduction takes place, both oxidation and reduction takes place are called redox reactions. In other definition, we can also say that those reactions in which one substance is oxidized and another is reduced is called redox reaction. Okay, now the next thing is oxidizing and reducing agents. As we consider the normal agent like the passport agent or driving license agent, then we know that these agents do that work. That means, for example, like passport agent make passport for us. Similarly, driving license agent make driving license for us, helps in making the driving license for us. Similarly, oxidizing agent means the substance which oxidize the other, the substance which oxidize the other. And as you know, if it is oxidizing the other, then it have to reduce itself, because without reduction itself it cannot oxidize the other. So we can say that those substances which oxidize others and reduce itself are called oxidizing agent. If we consider electronic concept, then you know that removal of electron is known as oxidation, and if it has to oxidize the other, then it has to receive the electron. So we can say that electronically they accept electrons. When they accept electron, then they oxidize the other. Got it? Similar concept is in reducing agent. Reducing agent, that means it reduce the other, it reduce the other, and for the reduction of other it have to oxidize itself, it have to oxidize itself. So we can say that those substances, those substances which reduce others and oxidize itself, reduce others and oxidize itself, are known as reducing agents, are known as reducing agents. Reduce others and oxidize itself are known as reducing agent. And as you know, for the reduction they have to give an electron, so we can say that electronically they donate electron, they donate electrons. Okay, now the most important part of oxidation and reduction, we have to find out which substance is going in oxidation process and which is going in reduction process. Like these reactions are given, not this, that was not. Okay, and we have to find out which substance is oxidized and which substance is reduced, which one is oxidized and which one is reduced. We have to find out. And sometime the examiner can also ask that find out reducing and oxidizing agents also, find out the oxidizing and reducing agents also. Got it? Now let's discuss the first reaction in which Fe2O3, that is ferric oxide, react with the carbon monoxide CO and convert into Fe plus CO2. Here the 3 2 2 these are for balancing. Okay, so again Fe2O3 react with the CO and make Fe and CO2. Now we have to find out oxidation, which substance is going in oxidation and which is in reduction. Very simple concept we can use. Look at reactant side and look at in product side and find what's going there. If I consider iron here and iron here, then it it have oxygen, it has oxygen, but now it do not has it lived, that means it loses oxygen. And you know that if any substance lose oxygen, then it is known as reduction. So that is reduction. Similarly here carbon monoxide and here carbon dioxide. To convert carbon monoxide to carbon dioxide, it has to receive oxygen. That means there is addition of oxygen, and you know that addition of oxygen is known as oxidation. So we can say that Fe2O3 ferric oxide goes in reduction in and convert into Fe iron, while carbon monoxide goes in oxidation and convert into carbon dioxide. Now the examiner can ask that find out reducing agent, and you know that for reducing agent, that means reduce other, that means oxidize itself. So the substance which is going in oxidation will act as reducing agent. Here carbon monoxide is going in oxidation, so it is work as reducing agent. Got it? Now consider the second example, that is zinc oxide Zn plus C equals to Zn plus Cu. Again here zinc is bonded with the oxygen, but here it loses, so that is reduction. Similarly here oxygen is added, so carbon is oxidized. So here zinc oxide reduced into zinc and carbon oxidized into carbon monoxide. So that is, this is reduction, that is oxidation. Again, which is reducing agent? The substance which is going in oxidation. Which one? Carbon. So that is reducing agent. Clear? Now the next one, zinc reacting with the CuO, copper sulfate, and product is zinc sulfate and copper. If you consider here SO4, that is sulfate, that is SO4, it has negative 2 charge, negative 2 charge. That means it is electronegative species. SO4 is electronegative species. Since electronegative species is removing, and you know that the removal of electronegative species is known as reduction. Here it is addition of electronegative species, so that is comes in the category of oxidation. Got it? Now consider the next example, H2 plus Cl2 forming 2HCl. If you consider here and here, then this chlorine and that chlorine, there is addition of hydrogen, there is addition of hydrogen, there is addition of hydrogen, sorry for that, there is addition of hydrogen, and because of the addition of hydrogen, because of the addition of hydrogen, you know that addition of hydrogen is known as reduction. That means chlorine is going in reduction. Similarly, this hydrogen and this hydrogen, electronegative chloride ion is added, so it is oxidation. It is oxidation. That means it is reduction and it is oxidation. Got it? Now H2O here, as if you consider that this oxygen is combined with the hydrogen and this is do not have hydrogen, and you know that that means it is removal of hydrogen, and you know that removal of hydrogen is known as oxidation. Similarly here this hydrogen is combined with the oxygen, but here do not, so that come in the category of reduction. Clear? Now next example, MnO2 plus 4 HCl forming MnCl2 plus H2O plus Cl2. Here and here we can identify that magnesium react combined with the manganese is combined with the oxygen, but here removal of oxygen, so that is reduction. Here chlorine is bonded with the hydrogen, but here it loses, and you know that removal of hydrogen is known as oxidation. Clear? Similar, now on the basis of electronic concept, Fe plus Cu plus 2 equals to Fe plus 2 plus Cu. Here you know that for converting Fe into Fe plus 2, 2 electrons should be removed, and removal of electron is known as oxidation, so that is example of that is oxidation. Here to convert plus 2 into 0, it have to receive 2 electron, copper has to receive 2 electron, and you know that addition of electron is known as reduction, so that's come in the category of reduction. Got it? Now, after that, the next point of our class is neutralization reaction. As we discussed this one, so let me finish it. What is neutralization reaction? The reaction in which acid and base react with each other. The reaction in which acid and base react with each other to give respective salt and water is called neutralization reaction. The reaction between acid and base to give salt and water is known as neutralization reaction. In these reactions, the H plus ion of acids, you know that acids give H plus ion as we discussed in the previous chapter. Acids give H plus ion and bases give OH negative ions. These H plus ion and OH negative ions combine and make water. Since here H plus and OH negative ions are used, that's why the use, that means we can say that their acidic and basic nature get neutralized. That's why this is known as neutralization reaction. Here the formed salt's nature is depend on the type of acid and base. Depend on the type of acid and base. As you know that when acid dissociates they give H plus ion and base dissociates gives OH negative ion. You also know that acid and bases are two types, strong and weak. Strong, that means they completely ionized and give maximum H plus or OH negatives, while weak are which do not completely ionize and give less H plus and less OH negative ions. So here the normal reaction, if we consider that in neutralization reaction H plus and OH negative ions are reacting with each other. If one mole hydrogen ions, that is H plus ions, are present, then to neutralize them we need 1 mole OH negative ions. If they are equal, that means 1 mole H plus and 1 mole OH negative, then they completely neutralize each other. But if one of them is strong and one of them which is weak, then the strong gives more H plus and OH negative ions rather than weak, because weak will not completely ionized. Okay, so here we can consider few examples to understand it. If a strong acid and a strong base react, then since both are strongs, if we consider both 1 mole, then they completely ionized and give equal amount of H plus and OH negative ions. That means here the H plus ion and OH negative ions are equal, so the complete neutralization reaction takes place. That means they completely neutralize each other. In this condition, the solution or the formed salt will be neutral, like HCl plus NaOH. Here H plus and OH negative combine and make water, while Na plus and Cl negative combine and make NaCl, like this. H plus Cl negative, Na plus OH negative. Here to understand about the mechanism, I divided into their ions. So that one combine and make H2O, while that one combine and make NaCl. Got it? Now the second case, if one of them is strong, like the in our second case we are discussing about that strong acid and weak base. If we take both of that 1 mole strong acid and 1 mole weak base, then strong acid completely ionized and give maximum H plus ion, while weak base will not completely ionized and give less OH negative ions as compared to the strong acid. Hence, in this condition, the concentration of H plus ion will be greater than concentration of OH negative ions. So since they are not equal, so the reaction in this reaction, these ions do not completely neutralize each other. Which ions remain? That is H plus ion. So we can say that H plus ions are remain in solution, which gives the acidic salt. Because of that, the nature of the solution is acidic, and the nature of formed salt is also acidic. So for example, HCl and NaOH. HCl is strong acid, but NaOH is weak base. So the formed acid, that is formed salt, that is ammonium chloride, will be acidic in nature, because here the H plus ions are not completely neutralized by this OH negative ions. If we consider the third example, in that weak acid and strong base, if we consider the 1 mole of weak acid and 1 mole of strong base, then it will not dissociate completely. That means it gives less H plus ion, but this is strong, so it will dissociate completely and give more OH negative ions. In that case, the concentration of H plus ion will be less than the concentration of OH negative ions. Since they are not equal, so they do not neutralize completely. Hence, the OH negative ions remain in solution. That means the solution becomes basic nature, or the formed salt will also basic in nature. For example, a weak acid CH3COH, when react with strong base NaOH, then they form CH3CONA, that is sodium acetate. Because of the strong base nature, it will be basic in nature. Okay, hope you like it. And the one topic which is remaining on our this chapter, that is catalyst, we will discuss in next class. Thank you.